Welcome to qnawire.
Hello students, for the first question it is given that the initial velocity of the train is u, which is 112 km per hour in the north direction, and if we convert it into meter per second, this is 31.11 meter per second, and we have to calculate the time required for the train to decrease its velocity to 40 km per hour. So 40 km per hour, and the acceleration is given as 2.5 meter per second squared in the south direction. Therefore, the final velocity will be 112 kilometer minus 40 kilometer, which is equal to 70 kilometer per hour in the north direction. As a result, if we convert it into meter per second, then it will be equal to 20 meter per second. Here we have to calculate the time, and we can use the kinematic equation v is equal to u plus at. Here we want to calculate t. So t is equal to v minus u by a. By plugging the values, here it is 20 minus 31.11 divided by acceleration. Here we can take negative of acceleration since the speed is decreasing, so minus 2.5. This gives the time period required is equal to 4.44 seconds. And for this second part, that is 1b, we have to calculate the length of the train. So length of the train can be calculated using this equation, s is equal to ut plus half at squared. Now let's plug in the values. Here s is what we have to calculate, which is the length of the train, and u is equal to 31.11 into 4.44 plus half into a is minus 2.5, the t is 4.44, the whole square, and this gives 138.12 minus 24.64. As a result, the length of the train will be 113.48 meter, which is the length we require. And for second question, it is given that the soccer player runs at a constant speed of, this is 2.6 meter per second, which we take it as initial velocity, and for next 18 meter distance, the s is equal to 18 meter, he speeds up with an acceleration of 0.45 meter per second square. In this case, we have to calculate the speed at the end of the run. So this can be calculated using the kinematic equation, that is v square minus u square is equal to 2as. In this case, we want v, so v is equal to u square plus 2as, and v is equal to square root of u square plus 2as. Now let's plug in the values. It is square root of u is 2.6 square plus 2 into 0.45 into s is 18, and if we simplify, we get the velocity value as 4.79, or which is approximately equal to 4.8 meter per second. This is his final speed. And for third question, it's given that a batter hits a pop-up that remains in air for 7 seconds before it hits the ground. Here for the A part, we have to calculate the highest point reached. Need to assume that initial velocity of the pop-up is 0, that is u is equal to 0, and the only force that acting is acceleration due to gravity, and this motion can be considered as free fall. So we can use the kinematic equation y is equal to ut plus half at squared, and in this case this term will reduce to 0, so it is minus half gt squared. In this case, acceleration is replaced with minus g. Now plugging in the values, we get half into 9.8 into here t is 7, so 7 squared, and if we calculate, the highest point is minus 240.1 meter. Here the negative sign indicates that it is moving upwards, that is against the force of gravity, and we can take only the magnitude, which is 240.1 meters. And for the second part, we have to find the velocity at which the ball returns to the ground. So this can be calculated using v is equal to u minus gt. In this case u is 0, so v is equal to minus gt, and this gives minus 9.8 into 7, and the velocity will be equal to minus 68.6 meter per second. So this is our next answer. Here the negative sign indicates that the ball is moving downwards. Therefore, the velocity of the ball when it returns to the ground is approximately 68.6 meter per second. Hope you find this video is useful. Thank you.